Today I'll solve one fluid mechanics numerical problem on viscosity. So here is the numerical problem. A thin flat plate of surface area 8 meter square is pulled parallelly to the upper and lower surface of a confinement with a 10 mm gap. The gap is filled with oil of viscosity 0.15 Newton second per meter square. One side and another oil with 3 times of the viscosity on the other side. If the force applied is 200 Newton, determine the velocity of the plate. Assume the plate to be in the middle of the confinement. Now here, so this is the plate. So the surface area of that plate is 8 meter square, and that upper and lower surface means upper surface and lower surface, the distance between two surfaces is 10 mm, the 10 mm gap. The gap is filled with oil viscosity in one side. So one side the viscosity of the oil is 0.15 Newton second per meter square. Another side the viscosity is 3 times of 0.15, and the force applied is 200 Newton to that thin plate. Now determine the velocity of the plate. So assume the plate to be in the middle of the confinement. Okay, so now here, so this gap is 10 mm. So now what will be the dy1? dy1 will be 5 mm and dy2 will be 5 mm. Okay, so now here is the solution. So first, what are the given datas? So now we know the surface area of the plate A is 8 meter square. Total gap between the surface D is 10 mm. So that is 10 into 10 to the power minus 3 meter. Now dynamic viscosity of the oil on one side mu1 is 0.15 Newton second per meter square. Another is dynamic viscosity of the oil in the other side. So that is mu2. So 3 times 3 into 0.15 Newton second per meter square, that is 0.45 Newton second per meter square. And applied force is 200 Newton. Now we know that shear stress is nothing but force by applied area. So now here that force we know, that is 200 Newton and area is 8 meter square. So now shear stress is 200 by 8, so that is 25 Pascal. Now the velocity gradient. The plate is in the middle of the confinement. So gap on the each side is d by 2. So d by 2 means 10 into 10 to the power 3 10 to the power minus 3 meter by 2. So that will 5 into 10 to the power minus 3 meter. So gap, so d by 2. So dy1 and dy2. Now so total shear stress on the plate due to the both layer of the oil, so that will be tau is equal to mu1 v by d by 2, because plate is moving with same velocity. So that is that shear stress in that one side plus shear stress is other side. So that is tau is equal to mu1 v by d by 2 plus mu2 v by d by 2. Now we have to calculate v. So now the tau already we know, so that is we have calculated, so that is 25. Mu1 is 0.15 and d by 2 is 5 into 10 to the power minus 3. Another is that mu2, that is 0.45 and v by 5 into 10 to the power minus 3. Now if we do the operation or if we do the calculation, ultimately we'll get that 25 is equal to 0.15 plus 0.45 v by 5 into 10 to the power minus 3. Now that will be 0.60 v by 5 into 10 to the power minus 3. Now if I do the calculation, ultimately we'll get 25 is equal to 120 v. Now finally we'll get v that is 25 by 120, so that is 0.2083 meter per second. So velocity of the plate is v is equal to 0.2083 meter per second. So that is the answer. That's it. Thank you.